Here's another example on linear programming. A manufacturer is to market a new feed meal, which is to be a mixture of two ingredients as follows. Ingredient A contains 40% bone 20% nitrogen and 10% lime and 30% phosphate, and it costs 48 naira 40 kobo per kilogram. Ingredient B contains 40% bone 45% of nitrogen and 5% lime and 40% phosphate, and it costs 41 naira 60 kobo per kilogram. Furthermore, it is decided that the feed meal will be sold in bags containing a minimum of 90 kilograms. It must contain at most 20%. It must contain at least 16% nitrogen. It must contain at least 30% of phosphate. It must contain at most 35% lime. Formulate the linear programming problem. How can we formulate this linear programming problem? You can make a screenshot of this because I have to rub it off to solve the solution here. So solution to this now, we have to formulate the linear programming problem. Our first step is to what? Writing down the decision variable. So we can let x1 be an ingredient of A and x2 be ingredient of B because we are what? We are writing it as a what? Decision variable. So we are saying that our x1 should be an ingredient of A and our x2 should be an ingredient of B respectively. So these are variable for the linear programming problem of ingredient A and ingredient B. So next is what? To formulate the objective function. So for us to formulate the objective function, we have to read the question very well and interpret the question. Remember that when we are formulating the objective function, we deal with maximization and minimization. So our maximization is profit and our minimization is what? Cost. If you look the question very well, you ask to what? Well, they said the question said A contains 40% of bone meal and it costs 48.40 naira per kilogram. That is 48 naira 40 kobo per kilogram. So it's a cost. This is not a profit, it's a cost. And when we are dealing with cost, we are going to minimize cost. So cost on ingredient of A, which is x1, is what? 48 naira 40 kobo. Cost on ingredient B of B, which is what? Which is 41 naira 60 kobo. 41 naira 60 kobo. So the total cost will now be what? The total cost will be 48 naira 40 kobo plus 41 naira. So in this total cost, remember that when you are dealing with total cost, since ingredient of A is x1 and ingredient of B is x2, we now have 48.40 x1 plus 41.60 x2. So this is the total cost for the ingredient of A and ingredient of B. So since this is the total cost of this, we now have what? Minimization Z 48.40 x1 plus 41.60 x2. So this is our minimization of Z. Since we have gotten minimization of Z for this, so what we are going to formulate the other constraint. If you look at the constraint, we have some constraint that have been given. That is bone, phosphate, some elements. So ingredient of A contains 40% of bone, 20% of nitrogen and 10% of lime. So in this case, we have been given solution to solve on it. So it means whenever we are dealing with ingredient of A, we are going to add what? Our constraint from there. So our ingredient of A is what? Ingredient of A is what? 40% bone 20% of nitrogen. So it's in percent. We have to what? Convert it to what? Decimal. That is 40% is what? 40 divided by 100. So from there, furthermore, it decided that what? One, the feed mill will be sold in bag containing a minimum of what? 60 kilogram. It must contain at most 22%. So from here, we can solve this. We have been given question to solve under it. So since the let me constraints. So we have bone. So the constraint on bone. So A contain 40% bone, 40% bone. So we have to convert 40% to what? Decimal. We have percent. We have to divide it by 100. 40 divided by 100. We are going to have 0.04. 0.4 x1, because our ingredient A is what? We represent as x1 plus our ingredient B. So we have to check our ingredient B where we have bone meal. So ingredient B, our bone meal contain what? Ingredient B contain 10% bone meal. So 10 divided by what? 10 divided by 100. We are going to have what? 0.1. 0.1 S2. So this is the constraint for bone meal. So next is what? A constraint for what? Nitrogen. Nitrogen. So the element. So what is an ingredient of A for nitrogen? We have what? 20% of nitrogen. So 20 divided by what? 20 divided by 100. We are going to have 0.2. 0.2 x1. Our x1 is the what? Our unit that we use to represent what? Ingredient A plus ingredient B. So ingredient B, we have to what? Look for what? Nitrogen. What's our nitrogen under ingredient B? Our nitrogen under ingredient B is what? 45% nitrogen. So 45 divided by 100. 0.45. 0.45 S2. So we have solved nitrogen. So our constraint for lime. Our constraint for lime. So our lime is what? Our lime is what? On ingredient A, we have 10% lime. So 10 divided by 100, we're going to have 0.1. So 0.1 x1 plus our lime under ingredient B is what? 5%. We have 0.5 s2. 5 divided by 100. 0.05. 0.05 s2. 0.05 s2. So lastly, our phosphate, our constraint on phosphate. So our ingredients on ingredient A, it contain how many percent of phosphate? It contain 30% phosphate. So 30 divided by what? 100. 30 divided by 100, we have 0.3 x1. It is in percentage. We have to change it to what? Decimal. So 0.30 divided by 100, then we have 0.31. So our x1 is what? Our ingredient. Let x1 and s2 be two types of ingredient A and B. That is our x1 is what? Ingredient A. Our s2 is what? Ingredient B. So that's why these are our ingredients A. These are our ingredients B. So we are not going to replace ingredient B because we have left x1 to be what? Ingredient of A. So whenever we see x1, we put, whenever we see ingredient of A, we add x1. That's why we have x1. It's a decision variable. And our s2 is this. Then our phosphate, we have 40% phosphate. So that's plus 0.4 s2. So these are the constraints of the linear programming model. So since we have found the constraint, so we can able to solve what? To solve the question under it. One, we have to find the feed mill will be sold in bags containing a minimum of 60 kg. Then it must contain at most 22%. It must contain at least 16% of nitrogen. So for us to solve this, since we have gotten this, so whenever we see anything, so this is a constraint of each element. So under the question that we are given, we'll just be adding. Remember that in constraint is a cost. We are dealing with cost. It means we are going to have greater than or equal to the percent of bone that we have been given, greater than or equal to the percent of nitrogen we have been given, greater than or equal to the percent of lime we have been given, greater than or equal to the percent of phosphate we have been given. So we now get our solution for this. So I will have to rub this rub it off so I can swap. So the feed meal will be sold in bags containing a minimum of 60 kilograms. One, if you look this question, since we don't have the constraint for the feed meal that will be sold in bag containing a minimum of 60 kilograms, so we will just represent it as a decision variable x1, x2, that is ingredient A and ingredient B. The addition of ingredient A and ingredient B will cost what? Will cost 60 kilograms. So we now have x1 plus x2. So whenever we are dealing with cost, it means our name is will be what? Greater than or equal to. Greater than or equal to what? The 60. So this is what? This is the minimum of feed meal that will be sold in bag containing a minimum of 60 kilograms. Two, it must contain at most 22%. So our constraint for the bone meal before that we did is what? Is 0.4x1, 0.4x1 plus what? Plus 0.45, 0.45 s2. And they have been giving us that 0.1 s2, 0.1 s2, 0.1 s2. And we have been given that it must contain at most 22%. It means the cost. The cost of the bone meal will contain at most 22%. So is that its cost we have what? Greater than or equal to. So 22% of the bone meal, we have to convert it to what? Decimal. We have what? 0.22. 0.22. So this is for what? For the bone meal. So number three, it must contain at least 60% of nitrogen. What is the constant for the nitrogen? The constant of nitrogen is before we got 0.21 plus what? 0.45. 0.45 S2. So these are our sign of the what? These are our constraints. That is a subject to a set of linear inequalities. So this is a what? Greater than or equal to. At least 16% of nitrogen. That is, must contain 16% of nitrogen. That is what? 16% to decimal 0.16. 0.16. Then our cost for phosphate 0.3x1 plus 0.4 0.4h2. So this is our constraint that we got before. And in this contain this is what? This is for what? Phosphate. That this for phosphate, it contains what? It contains 0.3x1 plus 0.4h2, and we have a cost at least 30% of phosphate. So when we convert 30% to decimal, we're going to have 0.3, greater than or equal to 0.3. Then lastly is it must contain at most 35% lime. It must contain at most 35% lime. So what is our cost for lime? Our constraint for lime is 0.x1 plus 0.05 h2. We have gotten this before. So I got this before. So since the book cannot contain it, so I rub it. So 0.1 x1 plus 0.05 h2. Then it costs what? The lime costs what? 35%. So it means we have to take 35% to decimal. 35 divided by what? 100. 0.35. So I'm going to have 0.35. So this is the solution from 1 to 5 to what? To the solution to the what? To the cost of the what? The cost of the nitrogen, the element we have been given. So lastly, since we have gotten this, our last step is what? To just add what? The non-negativity. If you look this question says our x1 and x2, our decision variable, is greater than what? Is greater than what? Is greater than 0. So we now have x1 add non-negativity, non-negative. So add non-negative. Now have what? X1, x2 is greater than or equal to what? 0. Since our x1 and x2, that is the coefficient of x1 and x2, that is ingredient A and ingredient B, are greater than 0. So we are going to have this. So this is the solution for the cost of what? Formulation of what? Of the linear programming problem. So we have formulated what? The cost of what? Of the ingredients of the A and B. So thanks you, and don't forget to share and like.